Hello, everyone. Good morning, and thank you for joining us in this early morning. You are the brave ones. I hope you had a chance to drink your morning coffee. And if you're still drinking it, we'll try to make it as enjoyable as possible and make it a good time for you. I want to start off with a quick question. By a raise of hands, how many of you have used GuardDuty and Booking.com anytime in the past 6 months or so? Amazing. Great to see so many hands. Thank you for being customers. We really appreciate that. And I'm Shachar Hirschberg. I'm a senior product manager at Amazon GuardDuty, and I help customers secure their cloud environments against threats. Next, I'm going to hand it off to my colleague Sujay to introduce himself.
Hey everyone, my name is Sujay Doshi. I'm a senior product manager with GuardDuty. I hope you're having a great time in Philadelphia and enjoying the Inforce conference. Hoping to have a great session with you, and I'll hand it over to Georgia.
Hello, I'm Georgia Bekeridou, and I'm yet another one senior product manager for Booking.com, and more specifically for the cloud security team. And
hello everyone. For a change, I'm Kushagra Sharma, senior security engineer at Booking.com, and today I'll be talking about the technical implementation of GuardDuty at Booking.com. Back to you, Sharon.
Thank you.
All right.
So today we're going to talk about GuardDuty. And the way I like to think about GuardDuty, which is our service for threat detection, is how a customer wanted to describe it to me. They said, I think about GuardDuty as the canary in the coal mine, where the coal mine is obviously their AWS environment. So they use GuardDuty to detect any suspicious activity they might need to go and look more deeply into, potentially wake up someone in the middle of the night if it's a very high severity case, but overall gain awareness on potential threats in their cloud environment. We are going to cover what is GuardDuty, the problems it helps solve for you as a customer, and its key benefits. We'll also discuss the evolution of the product, and then we'll put more focus on its runtime capabilities and how you can use it to gain more visibility in your cloud environment. After that, you folks here in the room, all the brave ones who made it here this early morning, are going to be amongst the very first people in the world to hear about a new capability we released just yesterday that will help you mitigate malware related to S3 buckets. And finally, we'll hear from the Booking.com team about their experience leveraging GuardDuty to scale their threat detection. When we started GuardDuty almost 7 years ago, we wanted to make sure that every customer, whether it's a 2-people startup or one of the largest enterprises in the world, can leverage GuardDuty seamlessly and easily to detect threats in their cloud environment. And today, several years after, we have tens of thousands of customers across virtually any geography and industry leveraging GuardDuty, including, by the way, Amazon.com and AWS. We protect millions of AWS accounts, S3 buckets, and hundreds of millions of EC2 instances to detect potential threats related to them. So what do we protect them from? We cover a wide range of threats, but to focus a bit more on threats we see specific to compute workloads, crypto mining remains a top threat targeting cloud environments. It's an easy way for adversaries to gain financially without having to deal with the company directly. We also see compute workloads being used for denial of service attack as a launchpad to attack other AWS environments, and leveraging the access to the compute instances to gain access to secrets and oftentimes to data, which is the ultimate target for adversaries. When we started GuardDuty, we wanted to make sure we cover a wide range of threats. And we started with 3 foundational data sources. EC2 flow logs that help us detect, for example, communication with suspicious command and control servers. DNS logs to help us detect, for example, potential data exfiltration via DNS requests. And CloudTrail, which help us analyze the activity that your users are doing in the AWS environment and detect potential credential exfiltration as well as anomalous activities that can indicate that someone compromised your credentials and gain access to your cloud environment. But we heard from customers that they would like us to increase the breadth of coverage and specifically add more data-specific coverage. So in 2020, we released GuardDuty protection for S3, which help us detect potential data exfiltration and destruction attempts that can be a part of a larger ransomware attack. And we do that by monitoring S3 data plane events. And then in 2022, as customers increasingly adopted containers and specifically Kubernetes technology, we further increased the coverage and added EKS protection, where we monitor EKS control plane to detect suspicious activities there. And then we continue to accelerate. So 2023, 2024, we continue to be busy, and we added 3 additional sources. First, we now monitor RDS for suspicious successful and unsuccessful login attempts, which can be the access point from which an attacker can further compromise data stores. We also added coverage for Lambda, specifically on the network layer, to detect, for example, crypto mining activity, which attackers increasingly started doing with Lambda compute to try to hide that activity from you as an organization. And that will be our main focus for today. We added coverage for runtime events using a lightweight security agent. And the runtime events are now coverage across EKS, ECS Fargate, and EC2. So we have all of this data. As you can see, over the past few years, we've been very busy at increasing the coverage across a variety of AWS data sources. Now, that begs the question of what do we do with it, how we distill it into insights for you. And we use a variety of techniques. The first one is threat intelligence, where we leverage both leading third-party vendors and our own threat intelligence to identify threats. And internally, we continuously track the latest attack patterns targeting AWS environment, and then add these patterns to detect them across the different activities that we monitor. We also maintain our own reputation graph for domains, and this is one of the largest graphs in the world where we classify domains as potentially benign or potentially malicious. And then when we see communication with them, we can classify the activity accordingly. In addition, we use a combination of stateful and stateless detection algorithms, where in the stateful algorithms, we can detect a sequence of events and identify if together, over time, they match a known or emerging attack pattern. And we have stateless rules, which are very deterministic because we're looking for specific things, and when we see them, we know it's a potential threat. We're also very heavy users of machine learning technology. We use this extensively across our detections, and specifically to detect anomalous behavior that can potentially indicate, for example, that credentials were compromised. And that is, as you all probably heard, the top attack vector targeting cloud environments. And lastly, we added malware detection, and that helps you identify better the root cause of a potential threat. So we have several ways we do malware detection, but specifically for compute workloads, we can take a snapshot after we see a suspicious activity, scan it, and see if we found malware in the EBS volume attached. And that helps you, as a security professional, identify the root cause of an activity. So if we see, for example, communication with a known malicious server, we will take the snapshot and maybe identify a malware file on that instance that eventually led to that communication. So we have a lot of data. We track multitude of data sources across AWS environments, and we leverage a variety of techniques to distill them into security insights. You as a customer get these insights in the form of security findings. We now have over 175 types of findings, and that is more than 5 times more the amount of findings that we had when we first launched GuardDuty. And we continuously add new detections almost every month. And you can consume these findings either via GuardDuty. You can use the GuardDuty console or APIs, as well as AWS Security Hub that can help you aggregate findings across accounts and regions. You can use Amazon Detective to accelerate your investigation and root cause analysis. Amazon Event Bridge, if you want to set an event-driven architecture and potential automated flows to navigate these findings to your workflow of choice, and a wide and growing network of partners ranging from SIEMs to ticketing vendors and more. So you can leverage the findings we create in your native workflows. From your perspective, all of the data sources that I've mentioned, except for the foundational ones, are manifested in the form of protection plans. So we have a dedicated protection plan almost for each data source that I mentioned. And the nice thing about these protection plans is that you can pick and choose whichever protection plan you are interested in. You also get a 30-day free trial for each protection plan for every account in every region that allows you to confidently evaluate the capability and estimate the cost for using it without having to worry about spending money first just to see if it's working. And now we're going to move to the runtime protection, which is a lot of our focus for today. GuardDuty runtime monitoring helps you get additional visibility and fidelity on your detections, as it allows us to gain visibility across new events on the operating system levels. As I mentioned, this protection plan is now available for EC2, ECS Fargate, and EKS. And by leveraging it, you can also identify threats sooner. And we'll see more about how it works very soon. Also, when we started working on this capability, we wanted to make sure that the experience to use it would be as seamless as possible. I don't even need to ask, but I know that probably most of the crowd doesn't like agents. You know, it's always a hassle to operate them, update them. You lose communication. You have a variety of issues, especially with legacy agents in the industry. And we wanted to make sure that when you use runtime protection with GuardDuty, the experience would be as close as possible to the agentless experience we offer with the other protection plans. And that led us to build a fully managed, lightweight security agent that can easily collect the events, the telemetry from your compute workloads and move it to our backend for processing. So let's do a quick comparison. If you're only using the foundational GuardDuty protection, we already have visibility via the CloudTrail, VPC, Flow, and DNS logs into the node level network events as well as control plane events. But when we add the runtime protection, we can now identify container-level network events. And that is important because you can have a single instance running hundreds of containers. So having that container-level visibility allows us to detect threats more accurately and also help you identify which container specifically is the one relevant for further investigation. With the runtime protection, we are also able to detect a variety of container-specific threats. For example, attempts to escape from the container into the underlying host to further compromise that instance. And we gain visibility across process-level events in the operating-level system. So now we'll see an example of looking at potentially malicious communication with a known command and control server. With the GuardDuty foundational protection, we're able to tell you that, hey, you have this EC2 instance. It's communicating with that known bad server. You should take a deeper look and ensure that it's not a part of a grander compromise activity that is going on in your cloud environment. We can tell you that you have something going on that machine, but if you are running multitude of containers on it, you won't know exactly which container is the one responsible. And you'll get a detection post-compromise because most of the time, once you have an outside communication outside, something already happened. With the GuardDuty runtime monitoring, you gain higher accuracy and visibility. So, and actually the colors are not great, but we can tell you exactly which container on that instance is the one responsible for the suspicious communication. Moreover, we can tell you which exact process and executable caused this communication, including providing the process lineage. So we can tell you, hey, a specific process spawned this one, and then that one, and that one, all the way down to the process that eventually performed the communication to help you understand and trace and investigate all these sequences of events to eventually remediate the root cause. In addition, since we're talking about containers, we also tell you which container image is the one related with this activity. And that can help, for example, in the case of supply chain attacks, where the image was compromised or manipulated. And by having that visibility, you can then easily trace it back to the root image and fix it there. And if you're using, for example, ECS in this example, we also tell you which task, instance, cluster, namespace, all of that rich context that helps you identify exactly what happened, when, where, and by whom to reach to conclusions faster and treat the root cause for it. It also opens capabilities for earlier detections of compromise. So let's see how that looks like. First, we have over 36 findings dedicated for runtime monitoring. And these findings are shared across EKS, ECS, and EC2. And we continuously add more findings pretty much every month to bolster the detection capabilities across these compute workloads. Some of the findings are similar to the ones you already have with the foundational GuardDuty protection, but you will get additional fidelity, as we've just seen, by using them. And some are brand new. For example, crypto mining. We spoke how it's one of the top threats targeting compute workloads. And with the runtime monitoring, you're able to see not only when a crypto miner communicated outside with a crypto mining pool, but also if it only executed on the machine without sending any communication outside, because now we have the visibility into the processes and activities running on that very instance, allowing us to help you detect potential compromises earlier, because we can tell you, hey, the crypto miner executed, even if it didn't communicate outside, you want to take action earlier than later. We can also monitor for command line arguments And that, again, provides with just earlier and earlier detection of potentially suspicious activities. So if, for example, we see a suspicious wget command running in a way that doesn't match the typical execution of commands in a container environment, you can already get a detection on that. And that wget command is potentially attempting to download a malicious file that can be further used to compromise your environment. So again, that earlier detection, moving you up the attack chain to reduce the chance of a compromise. And as I mentioned, we also have container-specific detections. For example, we can detect when a new binary is executed. As you probably know, the best practices with containers is that they should be repeatable and immutable. If you want to make a change, you typically do it via the CI/CD pipeline. We monitor the execution patterns, the activities running on a container. And when we see a deviation, a new binary executed, for example, where it doesn't typically happen, you also get an alert on that. Because maybe that container was compromised via vulnerability, and an attacker is trying to start the sequences of attacks there. And finally, we also detect fileless execution, which is a new attack tactic we see by adversaries where they load the executable into the memory and not into the file system to try to evade detection. How we detect all of these findings? We use a variety of techniques. We collect, as I mentioned, command line arguments, operating level system events, and we use extensive machine learning and pattern matching against new and emerging attack patterns to detect sequences of events. And when we build high confidence in these detections, you get them in the form of findings. And these findings help you as a customer detect threats related to your compute workloads earlier to ensure you can mitigate them faster. And now I'm going to hand it back to my colleague Sujay, and he will share more about how we designed the agent.
All right, thanks, Shahar, for your detailed insights into different offerings and features that we have in GuardDuty that helps to secure cloud workloads that are deployed on AWS. Good morning again, and thanks for joining. My name is Sujay Doshi, and today we'll be talking about the implementation and the deployment level details for different runtime monitoring offerings in GuardDuty. We say that there is low footprint, the lightweight nature. All of this comes fundamentally from the fact that there's no processing that we do on the agent. All it does is we collect the telemetry and we forward it to the GuardDuty's backend system, wherein the magic happens. There's different kind of detection techniques that we leverage. The threat intel-based findings, the stateless and the stateful rules, the ML anomaly detection, all of it kind of happens on the backend, as a result of which we are able to kind of keep the footprint of memory and CPU as low as possible. Moreover, using GuardDuty's runtime monitoring offerings, you can holistically apply runtime threat detection using AWS organization integration that GuardDuty already has. And it seamlessly allows you to deploy the agents across all the different workloads belonging to different accounts. Additionally, you can use the coverage summary dashboard from your delegated administrator account that allows you to get visibility into the clusters that have the agents installed. And it also gives you visibility into if there are any issues related to the health status that can then be consumed and work with your cluster operators to solve the errors. Now let's specifically talk about what happens for the workloads that are running on EC2, and more specifically even the ECS tasks containers that are running on EC2. For these workloads, we automate the agent management by using AWS Systems Manager, which basically helps you to install, deploy, update, and essentially manage your agents on these workloads. So once the agent is available, well, actually, even before we talk about what happens once the agent is deployed using SSM, if you don't use SSM, you can even use Linux CLI to RPM the agent bits from secure S3 bucket, or you can even bake your GuardDuty agent into the army that is then used to kind of deploy the workloads on EC2. So once all of this happens, essentially once you have the agents deployed in your workloads, we will be using, like I said, a mechanism to just collect the data on host operating system level events, and we'll ship it to GuardDuty backend. All of this happens and is facilitated securely using a VPC endpoint. So we take care of provisioning the VPC endpoint, managing the VPC endpoint, and more importantly, we'll also be incurring the cost that's related to having this VPC endpoint, since we use it to securely send the telemetry data to the backend. And as Shahar mentioned, once we have this data available in GuardDuty, we'll run it through the detection engine, apply different techniques, we generate threats and findings, which can then be facilitated into the broad ecosystem of different integrations that we have. You can use Security Hub for centralizing all your findings. The findings are available in Detective for investigation. And then broadly, you can consume them downstream into AWS partner systems using EventBridge. Now let's talk about workloads, specifically ECS workloads that are deployed on Fargate. There's a more seamless and a fully managed automated agent management capability that we provide for Fargate. One of the things that we've heard constantly from customers, right, specifically by the nature of the service that Fargate is, with this offering, you'd not be required to update your task definition every time you want to monitor what's really happening when the task executes. All you need to do from a security administrator and application owner perspective is update the task execution role, which basically will have the information on how and where the GuardDuty agent should be, or the service should be pulling the agent from, which ECR repository should it pull it from, what permissions are needed. And once that happens, as soon as you update the task execution role, every task that gets started, or there is for every new service deployment, ECS will auto-inject GuardDuty's security agent as a sidecar container. And rest, everything exactly remains the same. We collect the events, low footprint, no processing happening on the agent side. That's all shipped to the backend, and as I said, the magic happens. In case of EKS workloads, we are basically leveraging the EKS add-on, wherein your GuardDuty security agent is deployed as a daemon set. The daemon set instantiates an instance of the agent on every matching nodes in your cluster. What here then happens is there is a probe that gets injected into the kernel space in a sandbox environment, and there is a program that runs in the user space that helps you contextualize from all the system events that we collect with the information such as what's the cluster, what's the namespace, what's the pod information, and all of this, the collective set, like we talked about, is shipped to GuardDuty's backend using the VPC endpoint. So as you can see, we are trying to standardize the way you run your runtime threat detection programs for all the different workloads that you have that are either running using EKS containers on EC2, either they are running ECS containers, both available for Fargate as well as running on EC2 and your traditional EC2 workloads. We want to, using GuardDuty, provide you a mechanism to run that standardized program wherein the agent management, while it's not similar, but gives you that full automation where you focus as your application teams on application development, and security teams do not need to have the cost of ownership of the things we don't like, that is managing the agents. A very interesting distinction that I want to call out is, as Shahar mentioned, we have VPC flow logs and DNS query logs that gave us the visibility into the network layer and the threats arising from that. As we know, with the workloads that are deployed in the agent system events that we look at, there's also network connection events that we look at, which kind of provides us with similar details but more contextual information. So what we do that if you are using GuardDuty's agent on any instance, we will stop charging you for the flow log volume that generates from that instance. And that's a significant, think about it as a cost-saving parameter, wherein you additionally also get all the things that runtime threat detection has to offer with the use cases that we solve for. But a clear distinction is that we don't want to charge you for the same events and similar data that we get, but more contextually with the runtime. So that's one thing kind of, that additionally provides you defense in depth. But also remember, we do not stop processing. So we'll still process it. You still will get detection. It's just that you don't pay for it. So that's kind of, your backup or defense in depth, whichever way you kind of look at it. And we have customers across various industries and geographies already trusting GuardDuty to run their runtime threat detection for EKS, ECS, and EC2 workloads. All right, so moving gears to kind of talking about you being the first set of people hearing about the feature that we launched yesterday around malware scanning and protecting your applications that involves untrusted uploads. So really, before we dive deep into this, let's talk about Amazon S3 and common use cases. As we know, S3 has been a cornerstone in the digital transformation, where we see customers using it for a gamut of use cases. We see S3 to be the storage layer for deploying data lakes. We see S3 to be used by customers for storing log data. You also see it as part of your data pipelines wherein it's for storing your infrastructure information and infrastructure data. But then we also have Amazon S3, where applications such as web application or think about a website or content data that kind of gets uploaded and stored in S3, wherein you get this data from sources that either you don't trust or the data that you cannot establish a trustworthiness. Let's take some example of what do we mean by untrusted application uploads. And we'll look at this from the perspective of two different types of untrusted application uploads. Think about an example of applications wherein external users are uploading data to S3. Your social media application, wherein any user essentially can upload anything up to the files, up to the size restrictions. Think about healthcare applications where patients can upload medical records. Think about document management software solution. Think about your support case management, wherein support agents accept data from their customers to debug on what the issue is. Now let's look at from the perspective of internal users. Imagine you run an e-commerce website and you have your developers upload images to the product catalog, which is basically your files that you upload and it gets stored in S3. Also imagine about build management software pipeline wherein you store binaries in S3, which are then used by the build management systems to kind of download and use it to kind of build applications. What's common in these cases? And why is this a problem? How can we trust the provenance of these data sources? Do we know the data that's uploaded, if it's malware or not? Do we know the risks in case if the uploaded data actually turns out to be a malware. While when it was uploaded, it can be a benign file that's masked to be a malware. What happens if this file is now accessed by the application or even your users, and then laterally, we don't know what we don't know, right? The risks are huge. So we are now happy to introduce GuardDuty malware protection for S3, where using GuardDuty now, you can protect your S3 buckets from new object uploads that are masked as malware. Further, once you configure this on any bucket, GuardDuty automatically starts monitoring the new object uploads, will detect malware, will apply tags, will generate event notifications, findings, and more importantly, it allows you to essentially isolate this malware, detected malware, to some quarantine buckets. This is a fully managed offering from GuardDuty, wherein the list of malware signatures is continuously updated and regularly updated, and it's powered by GuardDuty's managed threat intelligence system. But more importantly, we provide seamless setup with minimal configurations for your application team and your security teams, wherein you no more have to manage the underlying compute infrastructure to run this scanner. So what are some key benefits? We provide with this quick enablement, wherein with few clicks, either using the console or CloudFormation templates or using API, you can essentially secure your data pipelines that you build on S3 with the fully managed offering from GuardDuty. Since it's based on a continuously and a regularly updated list of malware signatures, once a malware is detected, the finding that gets generated has contextual information around what's the S3 bucket, what's the metadata around that, the S3 object information, the scan-related information, and more importantly, also get the malware category so that your incident response teams can use tailored workflows to kind of respond to those threats. The solution is highly scalable, wherein GuardDuty now no more just detects, but also provides you the ability to do post-scan actions in form of object tagging, which then seamlessly fits into your downstream data isolation and quarantine and remediation workflows. But for me, the most important benefit that when we talk to customers is the reduced complexity, wherein neither the application nor the security teams need to manage the infrastructure to run this at scale. So application teams can focus on building the application logic, all of this while securing their applications that involves uploads from untrusted sources. So let's just take an example. We see there's an upload button in an application where external users are uploading data, all of that stored in a bucket called user documents. What we get if you configure Amazon GuardDuty here, you get the ability to scan, tag, generate findings, have metrics, and then you can define your, let's say, a Lambda function that allows you to move the data to a quarantine bucket depending on whatever is the operating procedures of handling the data. More importantly, the tag-based access control provision that you can use using tags allows you to restrict access to basically malware, but even when the scan is in progress. So you can define bucket policies on do not allow a user or an application to access this object unless and until it has the tag clean. So that's the power of kind of leveraging the tags within the solution. Before we get started on how you can set this up into your environment, let's look at the image on the left. And a very key distinction that I want to call out as part of this is, unlike other expansions or protection plans in GuardDuty, such as we talked about runtime monitoring, audit log monitoring, your Lambda protection, so on and so forth, wherein it is mandatory that on the accounts that you enable those features, you need to have the core GuardDuty enabled. Core GuardDuty here refers to the one that provides threat detection capabilities for foundational sources like CloudTrail management events and VPC flow logs from your EC2 instances. But with this feature, you can use this basically on any AWS account as long as you have an S3 bucket with synchronous storage classes, right? This is where we are getting or trying to get closer to the application developers who can basically use a managed malware scanning capability from GuardDuty as part of their application workflow without having to worry whether they have the threat detection detector from GuardDuty or not. So that's the flexibility that we are providing now to the customers. In terms of the configuration aspects, just provide the bucket name. You can even limit the scope of what we see or how or where all we initiate the scans from. So you can tell that in GuardDuty, only monitor objects that are uploaded to a specific prefix and not the entire bucket. Then you have the configurable option whether you want to tag your objects or not, and then simply provide the role that will give the permission to the GuardDuty service principal and establish that trust relationship so that we can perform that action on your behalf. Once the setup completes, we have the coverage summary dashboard, which will give you the list of the buckets for which you have set up this protection plan. And once you have the finding that gets generated in GuardDuty, just like any other finding, there'll be contextual information related to on what the bucket is, the metadata, the source, the malware category, so on and so forth. And then you can go to S3 console, and when you look at the bucket detail or the object details, you'll see a tag that's added, which can then be programmatically used for downstream actions. So I'd like to call now Georgia from Booking.com, who would now be kind of walking us through on how they scale threat detection for Booking using GuardDuty.
Thank you.
Thank you.
So, hello again. And I noticed before that on the question that who have used Booking on the last days, not everybody raised their hand, so I'm going to talk a bit about what Booking.com is. So Booking.com, it's a digital travel company that provides access to accommodation, flights, car rentals, and attractions. And our mission is to make it easier for everyone to experience the world. Our website and our application, it's available on 45 languages and dialects. So it's easier for people to navigate, choose, compare from a plethora of travel options to build the best experience for them. And to understand about our scale a bit and our presence, I have some nice numbers here. So you can see that we are almost providing like 30 million listings worldwide. And we provide different type of services. And like one thing that I like to highlight, it's like we have 30 different type of places to stay, from homes to tree houses to farm stays, and my personal favorite that you can book via Booking.com, it's igloos. So, as you can understand, with all these different type of services, Booking.com has a quite large infrastructure. A big part of that infrastructure, it is hosted on AWS. And with the millions and billions of numbers that we also measure here, you can imagine that there are quite of interesting things happening on that infrastructure. Yeah, interesting things are not only because our scale is large, but has to do also with the type of data that we're processing, because we're talking about customer data, partner data, and of course, credit card information. And that makes it super crucial for us to secure and protect our environments, our services, and our data. And enough with the business part and the numbers. We're not here to talk about Booking.com. We are here to talk about GuardDuty. So these numbers that you see on screen, they have derived from the amount of events that have triggered in GuardDuty the beginning of the year till May, so the last 5 months. You can easily identify that Booking.com it's a heavy users of Kubernetes workloads. That's why most of the events that we are receiving, the alerts that we are receiving for GuardDuty are related to Kubernetes. Most of them are flagged and tagged as anomalous behavior, and more specifically have to do with creation or modification of role bindings within that cluster, and also workload deployments in an unusual way. So these numbers are quite huge, and this is how we manage to keep our security teams very busy of checking on this anomalous behavior. So what is happening after? All these GuardDuty alerts are being ingested on our threat intelligence platform, where they're being enhanced with additional data sources, including identity information, infrastructure logs, and others, where they are being triaged and after that, when all these enriched events are being prioritized, are being picked up by our analysts, that they are running a set of defined playbooks for additional triaging and investigation. Depending on the outcome of this investigation, the teams are either have a list of suggested actions or the mandatory actions that are being taken, like attaching restrictive permissions, removing over previous permissions, or blocking services, or blocking the malicious services. And, I shouldn't have done that. Back. Sorry. And enough with the fluff and like the high-level numbers, etc. Now that I hope that you have a better view how AWS and GuardDuty helps Booking.com to enable our mission on a secure way. And with that said, I'm gonna hand it over to my colleague Kushagra, who is gonna talk about the technical details on how we are implementing GuardDuty in our organization.
Thanks, Georgia, and hello, everyone. To put emphasis on Booking.com's vision again, as a company focused on travel, we are constantly asking the question, how do you actually make it easier for everyone to experience the world? And this is why we invest in technology to solve some of the most complex challenges in the travel industry. We are partnering together with AWS to innovate and develop products that provide memorable experience to our travelers in every step of their journey. But behind the scenes, we want to ensure that this is done in a secure and compliant manner with a security by default mindset. Let's take a look at Booking.com's AWS cloud environment in a nutshell. As of today, we have over 2,500 AWS accounts, and this is growing exponentially as I speak. We have over 20 active regions in use. And on the long list of compliance scopes that we fall under, PCN SOX to name a few. So this gives you an example of the scale we operate in. Now, before we jump into the implementation bits, I'm sure many of you must have heard about the defender's dilemma, which states defenders have to be right 100% of the time, whereas an attacker only needs to be right once. But if you read the statement twice or even think about it, an attack is a series of events. So as long as you have robust detections to capture idly the entire life cycle of events, or at least part of it, it's already enabling your defenders to respond to threat, right? So I'll switch on to now the attacker's dilemma, which would make more sense, which states attackers have to get everything right throughout the entire life cycle of an attack. They need to ensure they bypass your controls, do not tip off any alarms, but defenders only need to detect them once. So as the complexity and the number of AWS services increase, it really gets difficult to prevent everything. So here's where you need to have robust detections, and here's where Amazon GuardDuty comes into picture, because it's giving you that at least one detection to let your security teams engage and get into the action. In short, the better the detections, the better the readiness of your responders. Now let's talk about how at Booking.com we operationalize GuardDuty from day one. So to start with, we enable the entire suite of GuardDuty features, be it S3, EKS, runtime, malware protection, on day one. At the same time, we enable GuardDuty on every member account in every region, again, on day one. So if you think about it, attackers try to look into areas which you're not monitoring. So it's very important to have GuardDuty protection in every enabled region, because it gives you the peace of mind and the confidence that in case something goes wrong, you have the necessary coverage as well as the monitoring. So what we did is that the moment you activate an opt-in region on AWS, GuardDuty is the first thing that gets enabled. So it's one of the core security services that we rely upon. So we have coupled the region enablement process along with GuardDuty activation on every member account in every region, again on day one. So along this journey, let's talk about some of the key takeaways that we had. First, automation is the key when it comes to security services or any service in general. Second, although we rely on a lot of custom in-house automation or external automation, it's really important to automate what you monitor. Third, there's a misconception out there that if you enable GuardDuty in every region, there are substantial costs involved. But on the contrary, if you think about it, if you have a region with no active workloads or resources, then ideally there should be minimal CloudTrail events, VPC flow logs, which means the cost should be minimal, right? Because you're not generating events which is linked to the GuardDuty pricing model. So it's really important to have visibility and monitoring in all active regions, because it gives you, again, the peace of mind to scale. Fourth, we always aim for visibility from day one approach, as it's very important to note the fact that you can only defend what you can see. So for your security teams, it's very important to have the visibility into your cloud landscape and see how your cloud infrastructure is growing, because with Amazon GuardDuty, this would give you the peace of mind to tackle every possible attacks and also make your security teams ready as you scale and your cloud environment scales exponentially. On that note, I would hand it back over to Sujay.
Thanks, Kushagra and the booking team for your key insights. So if you like what I talked about, there's a more deep dive session on the new feature that we launched around S3 malware scanning. So if you are around that time, please feel free to join us. It's right across, I guess. And then there's also a workshop to get your hands dirty on everything that we talked about, runtime monitoring, and in general, the threat detection capabilities from GuardDuty. On that note, I'd like to thank you all for spending your time, and I hope you kind of got insights. And then we'll be hanging around if you have any questions off stage. So thank you.